on our next guest, the lovely Jeff McIntyre of Mr. Industries. Hello, Jeff. How you doing?
Hello. You're running a hard bargain on those posters. I might have to get one actually.
They're flying off the shelves.
They're very cool. They're very cool. All right. Hi. I'm Jeff McIntyre. Let me see if I can share my screen and kind of get into a little bit of who I am. Let me see here. Share screen. Awesome. And then see if I can do my entire screen. There. Perfect. Okay. Is my screen up here? Are we good?
Yeah, you're all
Sweet.
good.
Okay, thank you so much. It feels like everybody here, I've been watching all of these previous presentations and they're very cool. So it feels like everybody kind of knows everybody and I'm like just some random guy from Colorado. So I'm excited to introduce you and share my thing, but this has been really cool. So I'm Jeff McIntyre. I'm a student from CU Boulder and I'm an electrical engineer. And I'm building a project called TinyCore and with the goal of trying to help non-technical students get into electronics and make electronics less intimidating for adults. So who am I? That's probably a good question. There's kind of three ways that I usually describe myself. The first thing is I'm an electrical engineer. I build things. I build cool stuff, hopefully. And then the second thing is a maker. I was a maker before anything else. I've always enjoyed tearing things apart and putting them back together and hacking things, making things that move and making things that make noise and light up. And then last of all, and probably the way that I personally like to identify myself is I'm a dancer. I love to do swing dance and do lots of exercise and things. So outside of all of my building and my work, that's kind of what I do for fun. So some of the projects that I've worked on, I've been making things for a long time. I've worked on a lot of things in the agriculture space, ag tech. One of the biggest ones I've worked on is the Ag Tag, which was a open source cow activity monitor. I call it a Fitbit for cows. And then I also worked on a project that was funded by the Mozilla Foundation as an open source hardware project called the Green Thumb Project, which was a ESP32 based greenhouse sensor kit. And I've done a bunch of Instructables and projects on open source hardware. So you can find more of my projects on facioergosum.com. I kind of borrowed that from Maker Faire several years ago. I loved it. It is a rough Latin translation of I make, therefore I am. And so that's where I post all of my projects. And I have a blog that I never write on, but I do occasionally add projects and photos of things and links to my Instructables there. So I'm more active on Instructables. I've got a bunch of stuff on there. I've been writing them since I was a little kid. So I'm a senior in college now, but I started writing Instructables probably back in grade school. My claim to fame was that back in, I think it was 2015, I have the top Google search for how to make a rainbow sheep. So if you type Minecraft rainbow sheep, that's my 14-year-old's like Instructables post. And so I've written a bunch after that, but that was the biggest one. And I've got a YouTube channel as well where I share some of my projects, and I've got my personal website. So let's talk about kind of what I've done in person. So a lot of this is all online, but I've also worked with a lot of students through a lot of different programs. So there was I'm originally from Kansas City. I'm now in Boulder, Colorado. But when I was in Kansas City, I was invited to be a part of something called Learn to Code to Learn, which was part of Kansas City Maker Faire, where we worked to teach kids how to code. And we actually ran some summer camps and after school programs in some of the inner city like parts of Kansas City. And that was a really cool experience. We actually started a few robotics clubs. So I've been in Best Robotics, First Robotics, and First Lego League. And I've worked with a couple nonprofits to create maker spaces and educate people on how to build things, how to use 3D printers, how to use laser cutters, and just get into making, because I think an important part of being human is learning how to create and be artistic and share, express yourself through what you make. So yeah, and then as I've gotten into college, I've gotten more into entrepreneurship and being able to help people start their own businesses, and then getting into engineering contracting, which has helped me pay for tuition. So that led me to this project, which is TinyCore. So what is TinyCore? So TinyCore is an electronics learning ecosystem that makes it easy for makers and creatives to add electronics to their project. Basically, I believe that building cool stuff with electronics doesn't require an electrical engineering degree. So I've got a group of friends that we all got together and we started this company, McIntyre Reeves Mr. Industries. We thought it was kind of a playful, like, corporate name, but in a fun way. And we made this product called TinyCore, which was based off of my senior design project, and now a startup. And it's all open source hardware. So these are some of the projects that students have built so far with TinyCore. We've sold almost 100 units at this point around CU Boulder campus. We also went to OpenSauce and we completely sold out there. And we've had a ton of users in the community build and submit open source designs. The Punch It boxing glove is a kid's toy. I like to call it a Bop It, but it's slightly more violent. Kids like it. It's really fun. It's a punching glove that tracks your punches and makes noise, and it's really cool. Long distance message box, that was something that I made for my partner when she went away on Christmas vacation and was long distance for a little while. Use the TinyCore to be able to send messages wirelessly, and then it would buzz and vibrate, and you could actually pick it up from like a different state and see a cute message that you've sent. The Cyber Jacket was something that my co-founder made. It's basically a light up motorcycle Tron jacket, and when you like lift the arms, you do turn signals, so you can actually tell people which direction you're turning on like a motorcycle. This one, I like to call it a whoop for your poop. There was a student startup that wanted to be able to track biometrics of gut health. And basically they found that by tracking a few different gases as well as your food intake, you could correlate what you were eating to the health of your gut. And so it was a little hockey puck shaped device made with the TinyCore. Goes in your bathroom and it would track the gas levels in your bathroom, and it would tell you if you're getting sick or not. We actually used that to try to diagnose. I got sick with some IBS type symptoms, and I was able to actually use their product to kind of detect what was going on. And it was pretty cool because I took a professional lab test, and they were very similar in the results. So I have a friend that builds model rockets. So TinyCore is going to be up in space soon, but he wanted to test it out. So he actually skydived with it to measure barometrics and acceleration. And I have another friend that was a mechanical engineer that built a light up graduation cap that plays Tetris. And you could actually control the animations and the game from your phone, or you could control it wirelessly with like a Bluetooth controller. And then lastly was my senior design project. This was actually what I built with TinyCore, and kind of why I built it. I was making a open source brain scanner using FNIRS, which is basically using infrared light to measure blood flow in the frontal lobe. And you can use that to tell respiration and stress levels, things like that. So you can use it for meditation and helping you sleep. Although I wouldn't necessarily recommend wearing my prototype to bed. It probably wouldn't be very comfortable. So those are some of the things that they've built. But of course, people want to know what exactly is it. So TinyCore is effectively the coolest ESP32 dev kit. I'm very biased, but that's my opinion. The coolest ESP32 dev kit that you can get. Has Wi-Fi and Bluetooth. Has built-in motion tracking, 6 degrees of freedom, so acceleration and gyroscope. It has built-in battery power and charging circuitry, a USB-C port, micro SD card on the back. It uses the ESP32S3, which has built-in AI and machine learning acceleration. And it also has 2 quick connectors so that you can plug in Adafruit and SparkFun compatible devices. What's really cool about the ESP32 is it actually shows up as a USB device, and you can actually use it as a MIDI device. So you can make game controllers. You can make keyboards and pianos and instruments. And you can even access the SD card over mass storage. So very good for data logging projects, for wearable technologies that are a little bit more advanced than just LEDs, and all sorts of kind of smart consumer devices. So the goal, this is the actual circuit itself, and I can pull up Altium. I am working on converting this all to KiCad. So all of the hardware is open source. It's all on our GitHub. But I know that, Altium is not a very accessible platform. So it's what our school uses. But I would like to get that all converted to KiCad as soon as I can so that it's much easier to modify. But we do have the actual footprint itself made in KiCad. So it's very easy for people to make expansion hats and modules for the board. So this is kind of the hardware. I was inspired by the octagon shape because I haven't really seen a lot of octagonal things. And also it's almost a circle, at least from an engineering standpoint, right? Pi is basically 3. And so I wanted something that could be easily made into smartwatches, circular robots, open source thermostats, smart thermostats, those sorts of things that are round. And so I wanted to make a board that kind of reflected that layout and was a little bit different than the traditional approach of like a rectangle. So expansion modules. The idea behind this was that I wanted to create your main platform, the Tiny Core, which is this brain that has a bunch of useful, what you actually need, sensors, all put into one. So you didn't have to just start with this ESP32 with a bunch of different things plugged into it on a breadboard. You could start with a really nice, clean thing and then add a couple different features that you actually need. And so some of those I wanted to make into expansion hats. So we have a Tiny Voice hat, which at the moment, most of these are in prototype stages, and we're working on getting them certified with open source hardware, but these are some like renderings of what they will look like. So the Tiny Voice has a microphone and speaker, and because the ESP32 can do Wi-Fi, you can actually do API calls to ChatGPT. You can run your own model, which is what I would prefer to do. So you can have your own offline little AI pin or talking agent, or you could make a smart home device, like a Google Home device, using the Tiny Core. The Tiny Sniff, that was what my friends with the Fitbit for Your made, and that is a gas sensor. So it's an environmental gas sensor with up to 3 different gas modules. And then the goal is to have there be a few different versions. So if you wanted to measure specifically methane or alcohol vapors or different families of gases, there would be different versions of the Tiny Sniff that would cover those. The Tiny Proto is kind of a culmination of where I want this to go. As I'm building the hardware out, and we're going to build a software platform that I'm going to demo, and after this, we also want to be able to teach people how to make their own hardware. So we wanted to make the footprint very accessible, and it'd be easy to just solder in whatever components that you wanted, sensors that you wanted, and kind of make your own prototype hats. It's all about making the prototype faster and dealing less with loose wires and bad connections, which is kind of the biggest headache in hardware. Tiny Display is a round touchscreen display, so you can make smartwatches, you can make thermostats, all sorts of other fun stuff. And then Tiny Glow is actually the board that we used in the graduation cap and in the Cyberpunk jacket, so that you can control up to, I think it's like 500 RGB LEDs. Of course, that changes depending on how bright you want it to be, but you can control a ton of RGB LEDs, and you can make smart lamps and things that light up and do really cool things. So let me actually jump out of here and kind of explain a little bit more about the whole ecosystem. So I have a website here. You can go to tinycore.cc, or you can go to mister.industries. And this is our website. And we've got kind of a demonstration of here's some of the user projects, and you can actually click on these and they'll take you to all the documentation for those projects. So this was the Cyber Jacket, and it's an open project on Instructables. I've also got my Instructable for the open source FNIRS headset. So if you want to build that, that documentation is right here. And then we also have Tiny Docs. So Tiny Docs is our documentation website. We have documentation for basically getting started as easy as possible. And so you can see here that we've, all of your standard setup documentation. And the goal is we want people to be able to get started with ESP32 in basically a matter of minutes as opposed to a matter of hours. My first time using ESP32 was a big headache, and I've heard that from a lot of people. So we wanted to make something that had a much lower barrier to entry where you could build IoT really easily. And part of that is our software platform. So alongside this open source hardware, we're actually building some software called Tiny Forge. And Tiny Forge, which we currently, let me see if I can pull up this demo. So let me pull it up. Perfect. So kind of imagine a software that's a lot like Fritzing, combined with Arduino IDE, combined with Circuit Lab, combined with an AI chatbot. And then all of that helps you design a schematic that you can export to EasyEDA, which is a free PCB design software online. You could probably also have that do KiCad, but right now we're just going straight to EasyEDA because they import JSON files. The idea is that we wanted to have your circuit diagram and your code all be able to be, and your documentation all to be in one application. So for example, I can open a project here. So let's say I have the Cyber Jacket. This is like the project for that. We have our INO, our Arduino code, which is right here. We can edit that. So, I can make another comment, import. And then what's really cool is that we also have a README file. So this folder itself is versioned to GitHub, and it has source control. So you have ownership of your projects. So let me do this, open this up. So there's our code. And if we open the README file, we can actually go over to the right and see the README here. And if I do here's my documentation. For example, we could copy the stuff that we wrote in the Instructable and put it here. It'll actually show up on the right here. And you can view this live. So what we are doing is we're taking all of the documentation on our website. You go to Tiny Docs, you find the first code snippet, and you say, oh, this is great. I want to use this code. Well, I don't even have to copy it. We're adding a button here that says open in Tiny Forge. It'll actually open this repository in Tiny Forge, which will load all the code and the documentation into the program, as well as a circuit schematic. So we're going to have circuit schematics saved alongside this, where you can actually do, Fritzing-like code circuit design and have that export into a schematic format. And then the goal is by the end of this, we want to be able to, we also have coding, or you can do drag and drop like Scratch. And then the goal is we want to be able to export these circuit diagrams and this code, which, there we go. To like an actual PCB design. So now you can actually start making your own custom PCBs. So yeah, that's basically what the project is and kind of where we're trying to go with it. If you'd like to help contribute, I'm a senior in college. I would love more experience around me. I love mentors and help and feedback. So any of that is super welcome. Please join our community. We have a Discord server. We do weekly office hours to help students with their electronics projects so that hopefully they don't get scared away from electrical engineering, and we can get more people building really cool stuff that makes the world a better place. So yeah, thank you so much. I don't know if I have any more time for questions, but
we're button right up against the end, but thank you so much, Jeff. This was really cool. We really didn't know what to expect from Tiny Core.
Yeah.
And
we'll get all your Discord link and your contact info, and we'll grab it all and share it so that way people can join you. And I love that you're also giving like office hours and stuff. That's really amazing. Really good.
Thank you.
It's like a pretty fun project to jump in on, folks.
Yeah. Thanks so much, Jeff. We'll talk soon.
Have a good day.
Bye.